Today's lesson is a continuation of the last lesson where you want to be able to say at the end that you can recognize the properties of equality, identity, commutative, and associative in an algebraic proof. Okay, so this is where we are going to apply all those properties that we kind of put together in the last video. As you would see them in a problem or a proof, as we are calling it, okay? So for each of these examples, we have different lines of an algebra equation, and in the line below it, we have changed something. And so our job is to be able to identify what property allowed us to do what we said we would do from line 1 to line 2, and if there's problems at the bottom that have line 2 to line 3, the same thing happens, okay? So that's kind of what we're going to be talking about in this video. So for example 1, in line 1, I have x plus 6 equals 10, okay? And then from there, I go to line 2, and it says x equals 4. So we need to recognize, okay, what allowed me go from x plus 6 equals 10 to x equals 4? And then I need to identify that property. Well, I'm looking at what changes first. So here, the x stays exactly the same, but I see that the 6 and the 10 now become a 4. So I need to think about, okay, what could have happened to the 6 to make it disappear, but make the 10 be a 4? But you're involving both values. So in this case, I would say that for 6 to not be there anymore, it needed to get canceled out. So since I'm adding 6, the opposite of that would be subtracting 6. Okay? And then that makes sense for 10, because if I subtract 6 from 10, that gets me 4. So 6 minus 6 is 0. And then remember that our additive identity said x plus, or anything plus 0 is still that thing again. So x plus 0 is still x. So that's why I can write x. And then 10 minus 6 gets me 4. So here, this one's actually the subtraction property of equality. Okay. Next example, we have in line 1, 3x equals 9, and then line 2, we have x equals 3. Okay, so we want to think about what changed. So on this one, the 3 and the 9 and the top line are changed to where they are in the bottom line. So now it's just x and it's just 3. So since we're looking at kind of what's going on first, I would see that 3 is being multiplied to the x. Wrong letter there. Multiply to the x, and 9 is now 3. So the undoing of things is kind of what we did on the last one. So because you're saying 3 is times x, to undo multiplication, you would use division. So it's like saying divided by 3, which makes sense because 9 divided by 3 is 3. And so that's what's left in line 2. So we would say this is the division property of equality. Okay. Example 3. We have line 1 is x minus 5 equals 4. Line 2, it says it's x equals 9. So because I don't have any 5 there anymore, I would need to undo that. So subtraction up at line or example 1 we had addition, we use subtraction to get rid of it. Here, this one would be the opposite. So I would use addition to get rid of the 5. That's what makes it go away on the left side. And then for 4 plus 5 is 9. So here we added something to both sides, so we would say it's the addition property of equality. Okay? So notice that I'm trying to recognize what happened, and what happened is what's going to tell me what property it should be. Okay? Example 4, in line 1 I have x divided by 2, which equals 14. And then in the line 2, now the division of 2 is gone, so I just have x, and now 14 is 28. Okay? So need to recognize what's going on here. So for this one, I see division of 2. And so if you think about 14, how would I get to 14 using a 2? Because I kind of have been doing that to both sides. So if I undo division with multiplication, that would easily get me to 28. So 14 times 2 is 28. 2 times x divided by 2 would be just x. So here, this would be the multiplication property of equality. Okay. All right. Now, moving on to some more complicated ones. Let's scooch our screen up a bit. Now, example 5, hopefully you notice that there are 3 sets of lines, and there are 2 possible properties. So for line 1 to line 2, we're looking at the property, or the first property, and then line 2 to 3, we'll have to explain how we got there for property number 2. Okay? And so it's always the one, like the change in between. So then since there's 2 changes, that's why we have 2 properties. So looking at line 1, I have in parentheses 6 plus x and then times x. So for that one, notice that from line 1 to line 2, the position of x and 6 plus x have been switched. So we need to first figure out how are x and 6 plus x connected to one another. And so since there's no sign in between, it's not addition, it's not subtraction, not division, the only one that would represent just by sitting next to one another is actually multiplication. Okay, so since it's multiplication, we want to look for a property that allows us to switch between or switch it around that multiplication sign. And so switching would correspond to commutative property, like we wrote in our notes. So I would say the commutative property of multiplication. Okay. Then for property 2, so line 2 to line 3, now we need to take notice of what else changes. So I see that inside the parentheses, it looks like the 6 moves to the right side and the x moves to the left side. Okay, so they're switching spots inside the parentheses. The x on the outside of the parentheses does not change, so I'm not worried about that one. But inside the parentheses, they're switching, so another key word, switching, and notice what sign they are switching around. It is a plus sign, okay? So it's very similar to the one that we just did, so it would be commutative because of that switching action that we talked about, but it's not switching around a multiplication sign, it's switching around an addition sign. So we would say the commutative property of addition. Okay? All right, example 6. Here I have from line 1 to line 2, I want to take notice of what's going on. So here the b is on the outside of the parentheses of a plus 7. But then in line 2, now I have a b with the a individually and b and the 7 are together. And it looks like I'm multiplying the b to the a and the b times the 7. Okay? So because of that, there's only one property where there's multiplication and there's addition in the same part, and that would be distributive property. Distributive property says that I can take any number on the outside of a parentheses that you're multiplying to, and you can distribute that to everything inside the parentheses. So I would say that this is distributive property, because it's b is going to the a, b is going to the 7. So that would be my solution, okay? Now for line 2 to line 3, I need to kind of look at what's going on here. So in the first term, b is switched spots with a. And then in the second term, b is switched spots with 7. So it's like the order switched for both of them. And we already has stated that because of distributive property, the b is multiplied to the a, and the b is multiplied to the 7. So we know we're switching around multiplication. So it kind of goes back to example 5's property 1 that we found, because we're using the word switching. So I would say it's the commutative property of multiplication again. Okay. Scooch this up again. Okay, and the last two here, there we go, squeeze that in. So now it says example 5 in your notes, and maybe that's just me in my copy, but just make sure it's example 7 in yours as well. So here, I'm looking at line 1 to line 2. And so for this one, I want to notice what changes. Now it looks like 3, 10x, and 4x actually stay in the same order. The only thing that changes for all your problem from one to the next is the parentheses move. So instead of being around 3 and 10x in the first line, they move around 10x and 4x in the second line. So remember, moving parentheses from one line to the next, that would be the associative property. And then for which operation, because there's two of them, all I see are plus signs. Okay, so it would be for addition. Right? Then for line 2 to line 3, I had that 10x plus 4x in the parentheses for line 2, but now both of those are gone and it's become 14x. So the parentheses are almost gone. Now here, there are two different ways of stating this one, okay? Now, probably the more mathematically correct one would be that because I'm saying 10x plus 4x is the same as 14x, so I can replace 14x or 10x plus 4x with 14x. So it's almost like you're saying that they're equal to one another, so you can replace them. And the word replace there is the key word. So, or like another way of saying this is like you're simplifying. Anytime you're simplifying or doing math, as I like to say, in your problems, this is where this property would come up. And so we would say this is substitution property. Okay. Another phrase that we could use is collecting like terms, which is a little less property-wise, okay? But also you could say simplifying like we said, but that also doesn't fit the category of properties. But it is the same idea, so that's why they're kind of okay. But substitution property is the correct use of this one. All right, and then go to the last one. So like in my notes, it says example 6. I'm not sure about yours, but just know that it's example 8. So it's our last one here. So looking at line 1 to line 2. Now here, there's no variables, all numbers, but I still want to recognize what happens here. So it looks like it's 25 plus 14 plus 15 plus 36. And then line 2, the only changes I see are that 15 and 14 like switch spots. So 14 goes to the right, 15 goes to the left. So they're switching, so keyword switch. So I know that it must be commutative. And then I need to figure out what they're switching around. Well, all I see here is the addition sign, so it must be of addition. Okay, so you kind of have to recognize what's changing and what sign is being used or being messed with, or allowing them to do that to recognize the full property. Okay, and then the last line here, or property. So from line 2 to line 3, like the order of the numbers don't change, but it looks like they're adding parentheses to it or creating parentheses. And kind of like what we said up in, the last example, you're moving parentheses around. Now here, there wasn't parentheses to begin with, so we're not like moving, but you can add them in, and that's the same like idea. So we would say this is associative because you're dealing with parentheses on this one. So anything dealing with your parentheses other than distributive property, like example 6, you're kind of getting rid of parentheses by multiplying through. This one you're putting them in, so you're adding them. So you're adding them in or putting them in, placing them in. So that's where it would be associative. And because there is addition everywhere around them, we would say of addition at the end. Okay? And that's kind of our application. So have a good one.